distinguished guests, and esteemed participants. Welcome to the first session of Golden Jubilee National Seminar on Future Trends in Maritime Industry. It's my privilege to invite our esteemed session chair, Commodore Rajiv Sridharan, retired Indian Navy. He is the Chief General Manager, CIO, GRSC. He holds BTech in Naval Architecture and Shipbuilding from CUSAT and a MTech in Ocean Engineering from IIT Gorakhpur, besides a postgraduate diploma in warship construction from IIT Delhi, also an alumnus of the College of Naval Warfare of the Indian Navy, and a postgraduate diploma holder in management studies from JBIMS Mumbai. An established naval architect with an experience of over 28 years in ship design and construction. During career spanning over 26 years in the Indian Navy, has been associated with prestigious capital ship design and construction projects, including destroyers and the indigenous aircraft carrier at various levels, right including project director level. Subsequently, headed the Central Design Office at Garden Reach Shipbuilders and Engineers Limited, Kolkata, for nearly 2 years, steering design of various naval, coast guard, and commercial shipbuilding projects, both at national and international levels. Conceptualized and evolved design of a full electric passenger ferry built for the government of West Bengal. Currently, heading the innovation and indigenization efforts at GRSC, spearheading autonomous vehicle development, implementation of AI and green tech solutions in collaborations with startups and innovators. Now, please join me to welcome Commodore Rajiv Sridharan, retired CIO GRSC, as session chair of first session Smart Marine Vehicle Technologies. Our first invited talk is on development perspectives of autonomous and unmanned marine vehicles by Professor P. Krishnankuti. I invite session chair to introduce Professor P. Krishnankuti.
Good morning, and I thank the head of department and the organizers for having me here this morning as chair of this session. I consider this an honor and privilege for two main reasons. One, because the introductory speaker in the session is my own professor, and it's a great honor to be here, sir. And it's my singular privilege to be a chair of the session. The other speaker this morning is a young professional and a leader in his own right, with whom I had the honor to deal with at a professional level on a number of occasions. The second reason why I said I have the honor and privilege is also because as an industry member now, two of the most important topics which is being spoken about today in this session, that is autonomous vessels as well as green tech, are synonymous with the future trends in maritime industry, which is exactly the topic of our seminar today and tomorrow. Autonomous applications, which I'm sure Professor will be talking about today, has got applications not only in the civil world, but a large application is there in the military world as well, both on surface and subsurface. The green tech is the future of maritime industry. And we have got not only the IMO regulations pushing this, the Government of India policies with respect to Harit Sagar, the MIV 2030, the Jalmarg Vikas programs, the GTTP, all these are pushing us towards green tech in the maritime environment. So I will, with your permission, sir, introduce you to the audience. Professor Krishnankuti doesn't need any introduction to all of us here today. But nevertheless, I will do I have the honor of introducing him. Dr. Krishnankuti, Professor Emeritus and Distinguished Animalist of this department. Dr. Krishan Kuti, who currently holds the position of Chairman, Hydrodynamics Panel of Naval Research Board, is also the Vice President of Royal Institute of Naval Architects, London, and serves as a member of the Research Advisory Committee of key research organizations of this country like NPOL and NIOT. Dr. Krishnan Kutti's work in academics and R&D is well known, and he has received national awards for his innovative work in biomimetic propulsion and his outstanding contribution to DRDO. He is also an alumnus of Stephens Institute of Technology, New Jersey, IIT Madras, Glasgow University, and has over 130 technical publications to his credit. It would be a privilege, sir, to hear you today and share your vast experience with respect to the autonomous field, which we are, stepping into an uncertain area. But I think as technology improves, we are there, and I think that's very much part of the future. Thank you, sir.
Okay. Yeah, thank you for the nice introduction, Commodore Rajiv. Good morning to, just good afternoon to all of you. And this is a topic I thought maybe suitable to the theme of the seminar. And also it's an area which is, as mentioned by the chair, it's an evolving, and still it has got a long way to go. So we have seen demonstrations of this technology in ships carried out by different agencies across the world. So things are being developed, but still it takes a lot of time to get a matured and comfortable level of its use as an autonomous vessel. So that is the status of it. The difference between the autonomous and unmanned vessel, we know that the autonomy of various systems on board a ship is being developed, or just many systems have reached a matured level. But the when you say it's unmanned vehicles, basically it's going to be fully autonomous, 100% autonomous, no man on board. So that's why you call it a unmanned vessel. So as I said before, there are, demonstrative, the technology demonstrations carried out with the different ships, which can be operated without any person on board, which you say it's unmanned ship. But it has been demonstrated only in a restricted environment, not to the open sea as such, which is more heterogeneous in nature. So that needs a lot of testing and acceptance level before it's put to operation. And obviously, Indian Maritime Organization should come into picture, coming out with the rules and regulations to look into the safety of the operation of such vessels. So that also it's in the evolving stage. So here, basically, I'm not a very specialist in autonomy or the artificial intelligence applications coming to that. Just giving a wider picture of the applications of this in this scenario, which will be useful for the people to understand where to concentrate on their future work and get updated with the knowledge and become a competent in the profession in future. So yeah, so generally we say autonomous underwater vehicles, as mentioned, the naval widely used by Indian Navy and also by underwater exploring agencies, and also may be used for bathymetric studies, underwater surveys, and all that, and also to look into the natural resources available in sea and deep sea. So for that operations, getting people there, it's often difficult, even though NIOT is now working on a project, it's a manned deep submersible, which can go up to 6 kilometers down the water. So that is also there, but I'm saying generally people don't risk with sending people there. So you go for autonomous vehicles for that. And gliders is also used, using the buoyancy engines, which goes in a, sawtooth trajectory. And it does without any person on board, widely used for the underwater surveillance and surveys and all that. So, and another category is remotely operated vehicles. Usually these remotely operated vehicles are, wired, it's connected, or underwater, it's difficult to have communication, wireless. So this ROVs are usually tethered, and even I think NIT also has gone up to such a depth using ROVs to collect the samples. ROV is the main thing, and it still have some, this maneuvering, sorry, the robotic hands, which can collect the samples and which are taken on shore and analyzed to understand the availability of different minerals in the deep sea and also. So that is one major thing. Autonomous vehicles and ROVs, the major difference is one is tethered and the other one is generally free, no wire connected to that. Okay, so autonomous bodies, basically you pre-programmed to do its activities and carry out the activities as per the program what has been, the directions given through the programs to do the manipulations or actions. So when you consider now, if you generally on the surface ship, you may be familiar with this term, MAS. It's basically a marine autonomous surface ship. This is a terminology which is being floated now mainly in IMO and the research agencies associated with that. So this is dealing with commercial vessels that operate with little or no human intervention. There is a classification given for that, where it uses a lot of sensors and softwares and communication systems to navigate and avoid collisions and perform its task. Basically looking to the navigation, guidance, and control of marine vehicles, which takes care of that. So based on that, IMO has come up with the, this earlier suggestions which has come up with the autonomy level classification of degree 1, 2, and 3, and 4. You can see that what are the different things. The degree 1 means you can see that the ship with the automated process and decision support with the safe errors on board, which takes other many systems on board ship. Many of the systems are automated, but not the whole ship as such. But you need people on board to look into this, operations, and if any variations or performance which are not acceptable, the people on board should take involve and correct it. Degree 2, it's a remotely controlled ship with safe errors on board. Again, the same thing, but it will have more control and operation from a different location that is possible compared to the previous one. So some sort of a remotely operated. Let's say it can be, since being a surface ship, you can remotely control, tethers are not required. You can communicate through, microwave transmission or satellite communication systems can be used to control that. So, and degree 3 is with again the safe errors on board, ship control of from other locations, but okay, no safe errors on board. So that is without safe errors on board. That is a situation, but it's remotely controlled, remotely operated. And the degree 4 is fully autonomous, unmanned ship. So these are the definitions of autonomy of ships, which has been coined. And there are many benefits. I think we may not have much time, but I just scanned through many benefits of the this automation brought into ships. One is a reduced operation cost. That means you can reduce the number of people on board and reduce the pay and so reduce the cost of operation. Then and also you are putting a lot of training for the people, the expense spent on that. and you have to carry food and other items on board the ship for the crew members. All these things gets reduced. Then the safety is enhanced. So there are many accidents which happens due to human error. So if it's automated, say human error occurs, maybe negligence or, fatigue and all that. So if you consider automated ship, so you're not, avoiding that. So that means it become more safe. So the actions will go as per, described. So then improve efficiency and environmental performance. And suppose the ship is going to face a route which is very rough, it can decide how to change the route to go to an optimum. That's a route planning and path changing. And control the speed depending on that. If it's reaching a port, the port is crowded with ships, there's no point in rushing to the port. So it can slow down, it can reduce the fuel consumption and things like that, reduce the emission. So this type of operations can be done if the ship is made autonomous. So it always sends this get the information, the crowding at the port, and information comes through satellite and other ways of communication to the ship. So naturally, automatically, a judgment will be taken or a decision will be taken to slow down the ship to instead of rushing to the place and just idling there. So, and also from the weather conditions, there's a storm prediction and things like that. It can always decide based on the input coming from the weather prediction whether it has to keep the same route or it should be away, because it can avoid very rough seas. And rough seas, that the added resistance will be more, and naturally it consumes more power and unable to maintain its speed. So all this comes in. So best thing is you find out a safer route, like what the Google map does. If there's a congestion, it gives another path which is easier. So something like that. Then coming the increase flexibility and scalability of that. So what is if it's a new services or depending on the demand of the delivery and short sea shipping and all that. So you can have the same ship operating during its operation itself. It can make a decision to call on a port or need not go to the port depending on the various other factors. So these things, that's a flexibility involved in that. Then enhance search and rescue at sea. So that means when you go for the rescue operations, when you used to put autonomous that instead of putting human people on board for the rescue operations, particularly in dangerous, hazardous environment. So this helps a lot. So there are different systems, electronic systems on board the ship, which are required to sense the data, get the information, and feed into the logic systems what has been developed for the autonomous operation, and make a decision and correct the operation. So there are different sensors, which are maybe different types of sensors used on board, and which are used to or required for the continuous monitoring. I'm not going to the details. There is sensing systems you need when you go for autonomous ships, unlike the ships what you have without the autonomy or with a manned ship. There are many more sensors required on board to identify the position with global position, or maybe with relation to the nearby ships, or with nearby any object. All these systems need to be identified. We need sensing systems for that. Then communication systems to receive and send communications. For that, there are different methods of that. And decision-making system, what to do. So that's the place where artificial intelligence come into place. So it can make its own decision, and it has to reach that level, because again that depends on the data, as Mr. Sambad was mentioning about that, getting the data, the availability of data, reliable data, quality of data. All these things matters depending on which you process it, and come to the decision what to be done with the operation of the ship. So that's the place where you talk about artificial intelligence, machine learning, deep learning, and all that. So these are the area, the things which are required in the when you talk about the autonomy of ship. Then actuation systems, the responsiveness of the ship to the commands should be fast enough. So that means nowadays you change the course and everything using the radar, or maybe thrusters, both thrusters or stern thrusters, or type of propellers depending on the azimuth propellers and all that. So how fast the system, the ship is able to activate the devices which can change the direction or be able to keep its course or reduce the motion, all these things should come up. It's all coming as part of the, these are some of the vessels which have been demonstrated for the autonomous ships with container ship and other ships here. There are a lot of connectivity challenges for an autonomous ship. So the communication is very important. How you communicate or get the data, how you communicate with another vessel, how you communicate with maybe the ground station, or so all this. There are different challenges in the autonomous ship development, and how to. There are different ways of doing it. So this picture is basically giving information about that, different ways with which the communications can be obtained. So if this is again I've taken from internet, the projected development of autonomous ship is like this. It's coming up. It's 2025. So that is a remote controlled unmanned ship. That is what is expected. And then 2035 is a autonomous, fully autonomous ship which can go to a commercial level of operation. That is what is projected. It may take more time for that to the open sea, and also operation in restricted waterways, entering into the port, harbor, which are more constrained areas. The maneuvering become very, very difficult. And so still it's in the evolving stage. So these are the different systems. It's difficult for me to see there. Okay, so there are different, so basically it's dealing with the data generation or acquisition and processing of this data, how it's done for a ship related activity. What happened? It's not moving. Yeah, I think maybe I have to go to the previous slide. Maybe the equation's there. No, wait, I think it's taking time for loading after this. Yeah. No, it's not blank. It is there, but I don't know why it's not coming. Wait, yeah, it's coming. I don't know. Okay, so there is this, just saying that how you achieve autonomy. See, nowadays what you do is you have a logical, expression or equation coming from out of physics. That is, when the ship is moving, what all parameters it's subject to, or what are the reaction and effects of that. When the ship is moving, you will have when any body, if it is moving, naturally you have a displacement, and when it's moving, it attains a velocity and also acceleration, isn't it? So these are the things which happens when you move one body to one by body from one place to same thing for ship. The ship have, you can see the terms. There are terms with acceleration, velocity, and displacement. Generally, when in ship terms, when you studied maneuvering or seakeeping, you know that the terms associated with displacement, you generally term it as restoring forces. And for ships, it is termed as a hydrostatic forces. When it comes to velocity dependent and acceleration dependent, you say it's hydrodynamic effect. So it's not, that's a general classification. So when it comes to velocity dependent, immediately we look to the drag effects, isn't it? It creates waves, and when it's moving at constant speed, create waves, and so that's related to damping. So that's how you term it as a velocity associated things as a damping forces. So when it comes to the acceleration part of the movement, you say acceleration is inertia, okay? Mass into acceleration, or so that is why we call it inertia forces. And for ships which moves in water, it will have the reaction of water to the acceleration. We call it added mass and things like that. So these are the various terms. So you have to get, this is a 6 degrees. I think the original thing, I don't know how somehow it's missing that. Original is a 6 degrees of motion. So when it comes to surface ship, generally you treat 3 degrees of motion, like, surge, sway, and yaw. So these are generally the deals. So that means you have the equations there, and you get the data of all these hydrodynamic quantities and hydrostatic quantities and the physical quantity of the ship, everything in this equation. And on the right-hand side, you put the excitation effects like the rudder effect, propeller effect, thruster effect, environmental effect, wave effect, all this comes on the right-hand side. And then you solve these equations to predict the position of the ship. So instantaneous position of the ship. So that is one way of dealing with autonomy. You have all this data available to you. You solve these equations, you predict the position of the ship. And that position determination will help in you to understand where exactly the position of the ship and how much it need to be, changed. So that's why I say it's a navigation, guidance, and control. Navigation is done with a global perspective. So if I want from Cochin to maybe another port, maybe in Europe, so that's a navigation, what you call it's a navigation chart, and everything is available. But through which place, it's already surveyed, sea routes are there. You have to go through that sea routes. So you have to follow the sea route. So the ship should be guided through the route. So that's what you call the guidance. And if the ship is deviating from the route, you have to bring it back to the desired route, which you call it's the control. So this is a difference between this. So all these things can be manipulated using this equation solving. This is one way how the people bring in autonomy to ships. So you have all this information. Unfortunate thing here is many of these values are estimated in ideal conditions, like say the coefficients, what or the hydrodynamic things, what you predict are taken from experiments or from numerical thing. And these experiments are done using, setups like planar motion mechanism or similar things, which are done in still water condition. So you get these coefficients or effects only in still water condition, which has been used in this equation for manipulation for the autonomy. But unfortunately, this is not strictly correct, because the ship is never operating in calm water. Ship operates in sea condition, waves. The ship, when operates in waves, its underwater contour changes. Thus, that means the hydrodynamics, what you predict, is going to be different. It's not going to be same what you have got from the lab or from the numerical thing. So that's why where you come with the data. The ship which is operating in ocean, and if you have the data of the ocean, data like the wave, direction of the wave, direction of wind, current, or maybe in restricted water is the boundary limits and all that. So you have the data there. What is that's input data. Now the ship is taking a trajectory. If you're having a data of the trajectory, that's a real-time monitoring of the trajectory. If you know the trajectory, you can plug in, develop the values here, or you can use it directly. So because these are real-time, so this data is obtained. So that's the difference between using a mathematical equation and using, the values coming in the equation from the typical experiments and all that, which may not strictly match with the actual performance of the ship. But you cannot take a risk by doing so when you put the ship into fully autonomous. So you have to have a correct data. That's what somebody was also mentioning about the quality of data to be used. The quality of the data which go into the prediction is very important. That's why when you consider the data processing, as mentioned by him, the data is available from different sources. A lot of data comes in. And you call huge data. So you have to know the reliability of the data for, you have to do a purifying process for the data to make sure the data quality is good. And once the data quality is good, then you have to train your computer, your system to use the data. So that's they call it the training data. Maybe 80% of the good quality data is taken as a training data, and maybe the 20% is taken as a test data. Subsequently, you train the model and then you test it against the 20% of the other part of the data. And if it's matching, you say, okay, it is meant. This is a continuous process, keep on going. So that is what you call the machine learning. So you have the data, you educate the machine, train the machine to understand, to predict the data and how to use it. And then it goes. So another area where you go is the artificial intelligence, where you use artificial neural network. Yeah, this is, you can see that artificial intelligence is basically it's trying to mimic the cognition of human beings, isn't it? So that is why the intelligence of human being is tried to make it artificially created, and that is what is done in the artificial intelligence. So how it's the human intelligence work is there is a system of neurons. I think there is 86 billions of neurons. You can see that on the right top corner, a picture of the neuron. So it got different components and all that. So 86 billion neurons are there in human brain. And these 86 billions creates 100 trillion connections in the human brain. So our artificial intelligence, I don't think it's going to reach there. It's very difficult. So this is the brain system. So see now you can imagine that if I am identifying a person, if I am just seeing Dr. Shiv Prasad here, I understand him as Dr. Shiv Prasad because my database in my brain has already stored his features. His image has been stored. All these images have been stored. So when I see him next time, through my senses, maybe through my vision, I can sense him through vision or through ear or any senses, depending on that. So immediately it correlates with the database and come with the decision, okay, this is a person. So this is same thing. If you look anything, if you are moving in a vehicle or taking a route, you're going home, whatever it may be, if you have all this data, the brain already has this data. What you're doing is whenever you find something new, you are trying to correlate the new data with the database already in the brain. And then you make a decision on that, okay, this is a route or this is a person or whatever it may be. So that is what is done in artificial neural network. It is trying to mimic the brain neural network in a computer base. So that is what is done. So one of the things what you consider is the people who travel, particularly in ships, many people are subject to seasickness. What is seasickness? Why does it happen? Because you are traveling in a normal platform, maybe a car, a bus, or through road. Now you are exposed to another platform which is subject to, not normal condition, which is abnormal for you. Particularly the seasickness is more severe for the first a few times. After that, you get acclimatized with the seasickness, so it's not a problem. That means by the time you travel, the database got updated. So when you're going for the first time or second time, the information what you get without your motion or observations and all that, it's not matching with the database already you have in the brain. So what happens? The nerves are one which sends signals to the vital organs, right? So it gets a wrong information is fed to the vital organs. So that means the organs are subject to unusual behavior which results in seasickness in the form of headache, nausea, vomiting, and all that. So that's, I'm saying that is one of the reasons. This is called a sensory conflict theory. The senses are getting conflicted during the travel, which leads to seasickness. So these are the, I'm saying that that's how operate. So if you, the data should get updated continuously. So, so you get the right information from the neural network. So artificial neural network is trying to mimic the same thing, which is required to handle huge data, whereas the machine learning may not be sufficient. So this is one of the thing I've taken from internet is a neural network system which predict the fuel consumption. What all inputs are required. You can see that the ship dimensions and speed and everything coming in. Many more data are required, and then it is transformed through the weight assignments of different activities. There's a transformation happening. There's a second layer, and then it goes to further layers, refined it, and finally comes with the fuel consumption information. That's output. So that's how it works. Yeah, if you see, that's what we have discussed. If you look artificial intelligence in the wider perspective, of which under that domain it comes to machine learning, and under the machine learning it comes to, within that it comes to deep learning. These are the terms which we have been hearing for a long time. And there is another one area which overlapping with, partly overlapping, this is a natural language processing. That is what you hear the Google Translate and things like that may be using it. So which you can identify. So this data is now, when we talk to our mobile phone, we may be using the local language, Malayalam. So, but this data is getting converted to the required language, and this data is stored. There's a collection of data from each and every communication is happening. What I am talking now is going to the YouTube. From the YouTube, the data is being collected by different agencies. You can see that particularly for marketing strategy and all that, all mobile talks and all these informations are collected. The data is stored and processed and used for marketing purpose or similar many other purpose. So this is another representation of the flowchart. I'm just lack of time. I'm just rushing through. Artificial intelligence got widely classified into two. That is super intelligence. You can see from the bottom. It's artificial narrow intelligence, general intelligence, and super intelligence. Okay, so these are the classification of AI, and we are through the first stage, maybe narrow intelligence, and getting into the general AI. But people are most scared about the third one, that is a super AI. Super AI is a situation where the machine will start making its own decisions. It doesn't need any input from you. So it goes beyond the human intelligence, which can go wrong, which can, put people to difficulty at a later stage. That's why you see that many countries are bringing rules and regulations in to curtail the use of artificial intelligence now. A bit scared now, but it's not happening now. The prediction is it may happen maybe 2050 or beyond. So that's a difficulty in that. Yeah, autonomous ships, I've already mentioned about that. The difference between unmanned ships and autonomous ships, general classification. The users also have mentioned. Yeah, guidelines, as I mentioned, when you come up with the autonomous ship, any technology, when it comes up, the rules and regulations, it should come into picture. See, now if you look IMO rules and regulations on ship maneuvering, it says what should be the tactical diameter, what should be the reach, and many things are specified by IMO to make sure that the maneuvering is within acceptable level, because maneuvering of a ship is mainly pertaining to the safety of its operation. So that is why IMO is coming to the pitch. Now, all these regulations are made for still water condition. Where do the sea trials? You might have seen that it isn't a calm sea condition, isn't it? If you look the ships built in Cochin shipyard, or where do they do? It really relatively calm sea. But the actual ship is never going to operate in calm sea, practically not. It's going to operate in a wave condition. But the rules which are prescribed for prescribed based on the trials conducted in calm water cannot be applied to a sea condition. So IMO is still working on that. It's trying to bring regulations for the ships operating in waves. So a lot of studies have been conducted. Research activity is going on that. What would be the deterioration in the maneuvering qualities of a ship when it's exposed to waves? So that's why I said guidelines need to come up depending on the type of autonomy, level of autonomy. Another important thing is cyber securities. That's any technology, it has got its pros and cons. So cyber security, if you make an autonomous ship, the Somalia people need not have to come to the ship to hijack it. They can hijack it from remote from their place. So that's a negative aspect of it. When you go for autonomous ship, naturally, there's a possibility of somebody getting into the system, into the software, and then take the ship. So that is so that means the cyber security is another area where you need a lot of research activities and safety should be considered. Then, okay, there are extensive testing required. As I said, a lot of data available, artificial intelligence and autonomous ship, lot of data is available. This is a continuous process which evolved to get a reliable system for this operation. But then you have to have a trained workforce for that, and there are many other acceptance by the stakeholders. When you say autonomous ship for cargo ship, naturally the ship owner should accept it. The shipbuilder should be able to do it, and the ports should be able to accept it. Whether an autonomous ship can come and the port facilities should get developed to accommodate autonomous ships. There are many things need to be done before a fully autonomous ship is put to operation. Okay, we have discussed the automation, the safety and efficiency we have discussed before. So it's safe, gives a better safe operation. But naturally, when it comes to a full autonomous ship, the level of redundancy of various critical equipments become important. Suppose one system fails, it's all electrical or electronic systems can fail. So the ship should not become stranded. So what levels of redundancy need to be provided to make it fully reliable? So all these things need to be checked. We discussed about the route planning, and another area is the ballast management system, progressive ballast and all that. This can be automized. You don't have to do it manually. So if you look to the future applications of AI into marine operations, it's particularly in a fully autonomous ship, you have to look into, not a single vessel operation, fleet operation, their interventions and all that. Then also the ship cargo, loading, unloading and tracking of cargo movements and all that comes in another area. Then it's clubbing with the blockchain technology of the business of dealing with the shipping. So different stakeholders come into picture for that, with autonomy coming in. Then prediction of weather and vessel traffic, all this comes in there. Yeah, this is basically use of this again autonomous marine robots, drone, underwater drones, and AUVs and all that. Is again the use and its applications. Data analytics applications I've already mentioned. Real time the data. This is a repetition of what I've already told you. Collecting data, and it includes data of the machineries and systems. There are different systems already automated. And it has got a predictive capability of any machine going to fail from its sound and other data which you get from the machine, and you can take steps to avoid catastrophic failure of this, and take predictive maintenance and correct it. Yeah, if you look, needs a lot of advancements in this area when you consider the data handling and use it for autonomous ship development. Yeah, so you have to come up with innovations in the various technologies to make the ship also eco-friendly with going to the green ship design and all that, because we are planning for green ship, less emission and all that. Instead of technology addressing only to the handling of the vessel, it should also address to the emission aspects and other requirements, related requirements. Then the climate change effects which can come on the design and all these things, even precise variations in the water levels and all can impair with the performance of um, uh, the vessel, particularly when it becomes autonomous. Then I think you're going to talk more on the green energy, and also I'm not going to that part of it. And yeah, I think Harry will be talking more about it. About alternate fuels also he may cover. Renewable energy use also he may cover. These things happen. I just finally want to, mainly there's challenges in naval architecture and maritime education. How the technologies, should be reflected. This because this and should anticipate the development of the technology over the period in the near future, and whether we are equipped as an education institution or research organization to cope up with this requirement. So that's very important, particularly when Ship Technology Department is organizing a seminar of this topic, and how the education institution can cope up with the requirements. So we need to have a good knowledge and skills improvement, including the application of all these AI, machine learning things and all that. It's a tool which is applied to all fields. So that tool and its application to maritime and naval architecture and marine vehicle operations and design should come in. So the curriculum should reflect that. And obviously need qualified faculty members who are exposed and experienced to this type of technology and its application. Of course, it's going to be multidisciplinary in nature. So obviously we can think of getting faculty from computer science or other related departments to give, more information about machine learning and things like that, instead of be venturing into that fully. Then the courses and syllabus should match with this update, and also a lot of computation efforts. Again, you're talking about handling of data. I think in one of the slides I mentioned that the human brain, the storage space is 2.5 million GB. That is a human brain memory space, 2.5 million GB. There's no computer so far which can match that. So the memory of that, I'm saying that, so the computational memory space required to handle huge data is enormous. So education institution which offers programs in this area should have such big computational facilities on its own, or it must be accessible somewhere else also. So that is important. Then all this data, how do you generate? Data is generated from actual operation. When the ship operates, data is obtained. Data can be obtained from numerical analysis. When you perform the numerical analysis of seakeeping or motions and all these things, you get data. Or when you do experiments, you get data. All this data go into the database, which should be used for the design purpose. Okay, or to train the machine learning algorithm. Yeah, so and also the people should get opportunities for the training to such things, and subsequent changes in rules and regulations which different agencies is planning to bring out. The people should be aware of that. And also the people who are working in industry, particularly young professionals, they also have to cope up with the developments for which continuous learning process is required for them. institute like Ship Technology Department can offer programs, maybe a certificate programs or part-time MTech programs to cater to the need of the working professionals, particularly in shipyards and related industry, who can get information and experience about the developments coming in the field, because it's an explosive situation. The knowledge is, the way in which the progress is going. You can see that it is enormous, and if you don't cope up with the development, you will be out of the race. So that's the situation. We also have to look to the research side and encourage more innovation in this. We can see that research is coming in material side. The design approach itself is changing. Manufacturing process is changing with the technology advancements. Digitization is very normal nowadays for data sharing. Nanotechnology applications in coatings, biomimetic propulsions are coming up. How to do that with that? So there are many things, including 3D printing and all that. So research activities also should enhance. It's not only the course program, academic syllabus and everything should enhance to the required, demand in future, and the research also should be encouraged. There are different areas where the research can go on. So thank you for the patient hearing, and I know I've taken little, maybe longer time. So if you have
Thank you,
any
sir.
quick
Any
question, which I am able to answer, yeah.
So good afternoon, sir. I had a question. So in case wherein the automated ship technology malfunctions or otherwise cause an injury or harm, on whom would the liability lie?
Yeah, that's what I said. See, the safety of the operation of marine vehicles is taken care by International Maritime Organization. So the rules and regulations on autonomous ship is yet to be in place. So if any unexpected and incidents happen like this, we expect IMO to look into that aspect. And when it comes to the port region, harbor region, the harbor authorities may have their additional rules and regulations on the operation. So all these things will come in place. So that has to come in place before the fully autonomous ship is put into, a high level of operation.
Thank you, sir.
Yeah, I think it's here. Yeah.
Afternoon, myself, George, course in charge at KMO School of Marine Engineering, you said. I have rather a concern than a question. That is now, when we see the marine engineers, BTech Marine Engineering syllabus, we need to give enough thrust on basic maintenance and operation for sure. But then, as you had mentioned, we need trained people. And when we go for a curriculum revision, including all these aspects of electronics, control systems, and data handling, as we were talking about AI, ML, DL, and all. So will it be too much on a marine engineer who is going to do this maintenance, operation, everything? So is it time to think of one more department on board a ship for all these operation? So maybe like maintenance engineers, and then a group of people for these aspects, to look into these aspects, rather than putting this or including this as a syllabus or adding on to the syllabus presently that they have. Can you throw some light on this? Thank you.
Now, first thing, I think what we are talking about, unmanned autonomous ship. So there is no way of putting another department and people on board ship. Okay, so that is ruled out. So what you have to do is train people, train the students how to handle such ships. Number of marine engineers are going to go down if this technology comes up. Number of people on board is going to go down. Operators coming to go down. But what you do is train the people on the other side who can handle such ships. So when the computer was introduced, there was a huge cry about the loss of job. Now you can think of the situation if the computer is not there, where the engineers will get the job. Their engineers are employed in computer industry, isn't it? Not in other manufacturing industry. So you can just think of that, cope up with the technology, train the people, they will get employed in that area.
Yeah, basically maintenance, I mean, not as a sailing marine engineer now. With an autonomous ship, basically maintenance is going to be onshore. Right?
Yeah, I think that's going to be onshore, right? Yeah, that's correct.
Thank you.
Okay, I think we have already overshot time. Thank you. Sorry, I'm taking. Want to.
Thank you, sir, for succinctly putting the whole thing in perspective with challenges. And we know that we have to break the threshold and then get into the autonomous and unmanned field. Thank you so much, sir. And it has been an enlightening session for all of us. Thank you.
Thank you.
Now I invite Session Chair, Commodore Rajiv Sridharan, to give a token of appreciation to Professor Dr. P. Krishnan Kutty.
The next speaker for this session will be talking to us on green technology. Shri Hariraj P. is the Chief Operations Officer of Smart Engineering and Design Solutions, one of the leading ship design houses in the country. Upon graduation as a topper from this department, Hariraj joined GTR Campbell, which is a marine consultants group, as a sister concern, and SEDS is a sister concern of GTR Campbell. Subsequently joined SEDS itself and has seen meteoric rise to COO in a short period of time. He has led several innovative ship design projects across the globe and is currently leading the way in developing green tech vessels for clients in the country and abroad. I have personal experience in dealing with some of the designs that he's developed, so I can vouch for it. I'm sure his insights on the field, in this field of green tech, is going to be enriching for all of us. I hand over the stage to Hariraj.
Thank you, sir. Thank you. Thank you. So good afternoon, all. It's a bit of an odd time to be presenting. It's a real honor to be here presenting in front of teachers who have taught us. Krishnan Kutty sir taught me maneuvering and seakeeping in my second and third semesters. And we had Madhyaragan sir who taught us corrosion and materials, and Shivaprasad sir who taught us ship design and construction. So it's always a pleasure to be here and a privilege to come to department and get a chance to talk to you all. When I was invited to speak, I thought we'll make a more of a interactive session because I represent ship design industry, and you are the people who are actually coming to the industry and you're going to run the industry in the future. And to put the subject in perspective, I am here, I am in this company, in this organization for about 21 years. And the time has never been so interesting. The last 2 years were the most, I would say, invigorating time that we had of all this last 2 decades. And when I look forward, you can only see opportunities. It's just what you want to take. And in India, being in India, it's again, it just opens a lot of opportunities. So we need to really have our aim right, have to plan right, and decide what we should do to get the best benefit of this opportunity. So in this presentation, I'm just trying to put some thoughts. Of course, it is driven by green and digitization, digitalization, as explained by previous speakers. But what I have tried to do is to put a perspective of the industry, what it is, what is there for us, and when we look from the designer's point of view, what we see in it, and what is there in India for it. So this I told, and I have to speak about this brief timeline of SEDS because this is also my timeline. And this is also at large the timeline of design in India. Because when I passed out in 2004, we had ship design companies, but companies which were mostly focusing on later parts of designs, which were mainly production design and detail engineering. And when this company was established by Mr. Anthony Prince, who is one of the leading figures in the international maritime industry, the vision was to create a design institute which can conceptualize designs which meets the demand of the industry today and in future. So I got really interested in that, and we have many from this institute working with us. And we got into really interesting projects. And in fact, if you look at each of these projects which we are doing, none of them are similar. You look at Japan, for example, you look at Imabari, they're doing bulk carriers. That too, you go to a handy size 35K bulk carrier, they do hundreds of them. They fine tune and they really master in it. But in India, we really don't have an industry that is existing now. We are actually, we are not even nascent. We are just too small when we look at India in the shipbuilding scenario. So we need to really define where we are going to grow. So we as a company was really kind of searching and trying to identify what should we be doing. So we did bulk carrier. We actually sat here in Cochin and supplied a full design to China. We did fast patrol vessels for the Indian Coast Guard. We did passenger vessels. Right now, the anti-submarine warfare shallow water craft, about which actually one of the awardees spoke about, very challenging. And actually, Satish Babu sir was involved in the initial designs, which when we worked in 2016. And presently, we are working on many designs for the European short sea. We are working on about 6 designs. And now we are getting a chance to work for the Europeans, mainly to conceptualize designs. So they have identified that in India, we have this capability to really come up with solutions which are not really influenced by existing thoughts, because we really don't have existing thoughts. We have to come up with solutions which are best fitting to the problems that is existing in the market. So before we speak about the technologies, this is the merchant fleet as of today. So we have all these vessels. If we categorize to 4 categories, we have small, medium, large, and very large. More than 50% are falling in this medium, large, and very large categories. And today, the industry is fully being driven by decarbonization. And a typical age of a vessel, a ship, is about 20 years. That means in the next 20 years, this entire fleet has to be replaced. So whoever is going to come out to the industry now is going to work on projects which are, the designs are to be developed and the ships are to be built to replace this massive amount of GTs that is indicated there. And This is the age profile. If you look at the 5 to 14 years and 15 to 24 years, these are all ships which are to be actually replaced in the near few years. And none of these designs are existing because nobody is sure what they should really design, what kind of fuel they should be using, what kind of cargoes they may be carrying. So now you look at the shipbuilding demand projections, any demand projections. Actually, though we talk about green and being environmentally friendly, I read about ChatGPT, for example. The energy being consumed by ChatGPT in a day is about 640 gigawatt hour. And that is the energy that takes to transport 300,000 tons of cargo by a ship for 24 hours. That is, a ship can actually move 300,000 tons of cargo for 24 hours at a speed of about 14 knots with that kind of energy. And we are talking about decarbonizing an industry which emits about 2.3 to 2.5% of global emission, transporting 90% of global cargo. So actually being from an industry which handles that kind of work, I feel we are really being punished for being big, because otherwise I don't really see the energy being spent when I search in ChatGPT, which I can actually do in Google and save 12 times the energy. So it's about, shipbuilding is the most regulated industry, and it is the easiest industry to actually put a regulation in because it's structured, like Class NK and other the classification societies and IMO. It's really structured. Now, whatever it is, human demand is increasing. Nobody is actually trying to reduce their demand, reduce their consumption, and trying to reduce the emission. That's really not happening. So we only see the demand of transportation increasing, and demand for ships increasing, and the emission increasing. And then we are trying to cut on really small things, which really doesn't matter, to be frank. Now, I will talk about this design trends and the drivers we have already established. These are digitalization and decarbonization. And in the design trends, I will try to speak about these things. We all know when we do a ship design project when you reach the final years, we are either given a project or you select a project, and you first decide a cargo, you're a cargo ship or a navy ship or whatever. You're going to design a ship for a purpose. And that is probably the most important decision that you're making, because finally, the money is paid by the end user. Like you and me are paying the price of a 20,000 TEU container transporting goods from China to India. Finally, we are paying. So it's all driven by the money that the customer is willing to pay and the cargo that has demand. And then if you really look at the cargoes, these are the predominant cargoes in the market as of now. So you can see the center light blue line is the bulk. So if you really look at, say, 2030, 2040, 2050, the bulk transportation remains the majority of transportation. And you can see the below lines, the containers and other cargoes, they are also increasing. Now, when you look at design, how do you make a design green? You make design green by transporting more with equal or lesser amount of fuel. What I have seen is in 2004, let's say a 30,000 ton deadweight bulk carrier, to travel at 14 knots, it used to consume about 5,600 kilowatt of power. So that used to be what we call the CSR power, that's continuous service rating power for a 30,000 ton bulk carrier. And today we are talking about 4,500 kilowatt. So that's about 17-18% gain, which is already, we have achieved a level. And we all know, when you look at this cargo, you remove the other cargo, the rest all are large ships, big ships, heavy, high displacement vessels. And we have studied in our resistance and propulsion, about 80% of the power that is required is to overcome the friction, the frictional component of it, which actually has no connection to the flow around it except for the shape of it. And when you look at, again, there are segments. If you have done your project, you might have seen handy size is a segment where you try to limit the length of a ship to about 180 meter. Then you have handy max, you have supramax. Each of these categories of ships are actually defined by either a port regulation or a port limit or a lock limit or something that is there in your major ship channels. So you are designing for a particular set of dimensions. Now, how you make it greener? Within that particular dimension, can the ship carry more? So you make it fuller. You increase the CB. Like we studied a standard CB of a bulk carrier. If you actually, even I think in PNA right now, it says probably 0.78 to 0.81. But now the CBs are 0.85 to 87. So you are making it really full. And the surface area is also increasing because the ship is full. And the frictional component is basically a standard formula which is existing with slightly form connected changes. And then we try to optimize the wave resistance and the flow to the propeller. So there comes the CFD. And the usage of CFD technologies have phenomenally changed how we approach a design at an early stage. To put things in perspective, in 2010, for us to run one CFD calculation for one speed, one displacement, it used to take about 14 to 16 hours with the capacity that we used to have. And I have worked with Marin for about 14 or 15 model test projects. Marin used to take probably about 6 to 7 hours at that point in time. But today, with the 11,000 core machine that they have, they can do probably thousands of iterations in one day. That is the capacity that has changed. And that is the flexibility that it gives to designers to define your variables and then try to reach a solution that gives you the best efficiency. So the usage of tools have definitely improved, but I feel when we look at it, whatever is this 20% component of wave and the flow related aspects, we've optimized it too much. Now, where do we really see a hydrodynamic gain from optimization? I really don't know. I feel it is non-existing, but then it is like, actually I was reading this Carl Sagan Cosmos book. In fact, I am rereading it. And there is a paragraph which talks about what human took to travel from Europe, Netherlands to China in 15th century. It used to be 2 years. And it cost some 1% of GDP of Netherlands or something. And that's what it takes us today to travel to Jupiter and take the entire photo for the Voyager 1, not today, in 1979, just before he wrote the book. So the human intelligence is growing amazingly. The drive is moving high, but then still there are these look like has reached the physical limit of what can be extracted in terms of efficiency. Then we look at other technologies. Now, let me go to that. The fuels. So now we are kind of exhausted with what we can extract from the hull. So they're fully focusing on fuel. And again, we are this industry, as I said, it's like the workhorse of the world. And it has been doing a very efficient job over the years of development that has happened for the industry. And today we are trying to replace a fuel system, which is well established and with very good infrastructure to all this possible alternate fuels. So when we look at, you might have heard about green, blue, and brown fuels. So something that is generated from green electricity. And hopefully one day the green electricity becomes so abundant that nobody really cares about spending some more money and making it back to a fuel, like e-fuels, what they call, and consume it. Then it's okay. It's perfectly green. But today, if you really watch the market, how it goes, Maersk went a couple of years before high on methanol. They told green methanol. They're going to do everything on green methanol. And then many people thought, okay, that's the right way. Let's also do the green methanol. Anyway, Maersk is telling that it is methanol. And this year they have kind of changed to LNG. And because where is the fuel? It's a very interesting thing. And then why should somebody pay higher money and buy fuel for a ship where there are thermal electricity, when there are daily consumers like you and me who is ready to pay higher for the car fuel? And ship is the problem. Maritime industry is the last in the row to get access to this greener fuel, whichever is being created. So whatever we think are the green fuels, it's very difficult for the industry to actually get a hand on it unless you are ready to pay extremely high. Like say Nike is ready to pay higher for transporting the shoe, because you really don't mind paying 15,000 rupees and buying a pair of shoe when today that is costing 10,000 rupees. That 5,000 is directly coming to you and me. But that's not the case when it comes to a kilogram of rice or your fuel, the crude oil that you're using, or whatever large kind of commodities that are being used. But saying that, when you look at design, you're being driven by these ones. Now, what happens when you try to carry a cargo? Let's say who are the major contenders? Contenders are LNG, methanol, ammonia, or liquid hydrogen, probably if it comes green. All of these come with a lot of complication. And again, we should not forget that the ships are designed for carrying cargo in the most efficient way. Now, all the four fuels have a energy content which is less than 2.5, 1 by 2.5 times of crude oil. So if the crude has say 42,000 kilocalorie per kg of energy in it, methanol has, I think it's about 18,000. Ammonia has something around that. LNG actually has better energy content, but it has its own complication when it comes with boil of gas management, storage of minus 162 degree fuel on board, managing the boil of gas. So we are all trying to do it to reduce carbon emission. What if we end up emitting methane in that process, which is 44 times greenhouse gas potential gas, ammonia, which is more corrosive, chemical. So you are exposing an entire community of mariners to a more complex fuel, like Sir mentioned a while ago. So we are actually being driven by a lot of interests, which probably, hopefully, we will all attend. But again, when it comes to design, we have a problem of integrating a complex system which weighs heavy. That means a ship, a 30,000 ship, because why I'm taking 30,000 is that is actually what can be done in India. So I was looking at what India can do. A 30,000 deadweight bulk carrier will increase its weight, the lightship weight, by at least 400 to 500 tons if you introduce any of this cargo. That is, if the lightship weight is 9,000, you will be increasing probably 7 or 8% of the lightship weight, which the ship has to carry around the entire lifetime. And you're adding cost by about 30%. So if the ship costs about, say, 25 million to build, you add any of these fuels. Okay, the lower side may be methanol, to the higher side may be ammonia or LNG. You add the vessel's cost by 30%. And again, that all will come back to cost. And any cost, I feel, can be connected to greenhouse gas emission. It's not that if I am earning something more, I'm definitely emitting somewhere, which probably I understand or sometimes I don't understand. And so in design, but we see a constant trend of everybody asking for other fuels. And this is what exactly is happening now in the industry. This is one of our designs where you make it ready. So nobody wants to really get into and make a decision because you really don't know what decision you should make, because you don't know whether you will get fuel. If you design the ship for LNG, and what if you don't get green LNG after 5 years? So the left side will see a design which, instead of making it with this new alternate fuel, you still design it with conventional fuel. You design it as much as possible fuel efficient, so that you can reach to the phase 3 of EEDI, and then probably you reduce the speed and you basically push the present market situation as much as possible, and then decide on an alternate fuel when you're clear about what you really want to do. So this is one of our designs we are discussing. And the very important thing that we are seeing is the endurance considerations. So again, when you design, you have your cargo. I missed about talking about cargo. The cargo pattern is also changing. We see a lot of new cargoes which demand a lot of new volume, like the windmill components, the project cargoes. The increase in green is actually driving the type of cargoes to change. So now the route and endurance. So typically each of these vessels used to have standard endurance of 18,000 nautical miles, 25,000 nautical miles. And the entire industry pattern of cargo transportation used to be linked to that. So people knew when they have to bunker, where they will be bunkering. Now you cannot really carry, let's say, again, take a 30,000 ton bulk carrier. You have 1,500 cubic meters of heavy fuel oil on it. And if you need similar endurance, you need about 4,000 cubic meters of, say, methanol. 4,000 cubic meter of methanol is also that much times heavier, because methanol, again, the density is more. It is heavier than fuel when you compare the equal density. So you really don't want to carry that much energy, because finally you're converting it to energy and using. So people are now looking at reducing the endurance in certain, it's like project to project discussion. So every time when a ship owner comes to us with a green thought, this is one standard question that now comes up: how much endurance you need? Do you really need a standard 5,000 nautical mile, or can you manage with 1,500 nautical mile and refuel more? And then hull form and powering. So we already had discussion about hull form and powering, and the latest project we are actually working, the CFD optimization is a combined optimization with propeller. So now the hull, the flow pattern, that phase is over, and now you are combining what is the best combination that you do. So typically it used to be you optimize the hull, you find what is the best weak, then you try to design the propeller for that. Instead of that, you are now optimizing the hull propeller combination, which we feel is going to really help a bit. And this image that I have put here, this is one of the first research project that we did with Marin, where the cavitation patterns were studied for whether we can improve the noise aspect with a future perspective. So this test was done in Berlin, in the Berlin Technical University, which has at that time had the largest towing tank. And and the propeller design, again, it is one of the key skills. Like you all know about Wageningen B series, which used to be our standard series when we used to do project, and it's still the standard series being used. But Marin has reached F series. So they have passed through B, C, D, and right now it's the F series, which gives slightly better efficiency, and it has more thought, or it is being designed with more thought towards noise. So you will have probably thicker blades and probably more attention to cavitation. And probably after some time that becomes a public data and we all will get access to it. But now when we come up with a cargo ship design, and if you go to Marin or that kind of institution, they are in that level of thing. And then the selection of ESDs, energy saving devices. Again, these are all things which are trying to optimize the flow to the propeller. There are different options. And we don't really see it as a green design thing. It is just, we try to somehow extract 1 or 2% from somewhere with really limited effectiveness, because you keep a thin fin just in front of a propeller for a ship which is supposed to be sailing in the rough seas. And 2 years down the line, you really don't see the wake equalizing deck. It might have gone somewhere, and then you cannot really go to a dock. You just sail with whatever you have. And then these two, now when it comes to the friction part, these two part, that is the air bubble system, basically to have the system and to have an air bubble along the hull and reduce the friction. Here we see, earlier it used to be, there used to be companies like Silverstein, which had a single bubble creator kept forward of the hull. Instead, now we have this multiple bubble creators with alpha level and all. It definitely gives certain advantages with flat bottom vessels and all. And wind energy, which actually reduces the thrust required directly. So it's not like as a resistance, but if you are in a good wind area, you get direct reduction. And we right now in one of our design, we are using this a vessel which actually operates in the Mediterranean for predominant amount of time. And if you're say traveling between Greece and Spain, those kind of areas where you have good wind, this seems to be a good possibility. Then again, green future requires really good designs. The designs have to be optimized. Design has to be matured at a very early stage. And the tools have really evolved much, and it really allows designers to fine tune and design a ship which is actually produced in the computer. And if we really plan well, I still feel the industry has not really tuned to it fully, in India at least. If we can really spend enough time on design and fine tune the design well, the whole greening is not just ships in operation, but the construction period, if we can reduce, that's also saving. So I feel that can be done. And probably we are discussing with all the shipyards on these particular aspects. Then why I have put these things, these are projects which we are working on it, and everything has something in it which is green. The first one, we call it Econova. It's a small vessel. And the interesting part is, this is for a segment called European Short Sea. And European Short Sea is basically the vessels which are operating in Europe, who use ships extensively for their domestic transportation. And it has different sizes, again, limits which are defined by locks, seaway, the dimension of routes that are there. And 90 meter is one key limit. So vessels below 90 meters used to be about 3,800. Now people are trying to push, and we have reached this 4,150. There are about 3,500 ships to be replaced in about 3 to 4 years if they have to meet the regulatory environment that they are in. Everybody has to pay for the carbon that they are emitting. So there in this one, the buyer wanted diesel electric, which we are still trying to understand why diesel electric when you directly see emission increasing with diesel electric. But when you really look at overall operation, your slow speed operation, your high speed operation, the combination of engines that you can use, it seems it can give some advantages. The second vessel, it has potential for moving to any fuel, that's green, methanol or ammonia or LNG. And other designs are, you can see the right one with wind. It's from a company called EconoWind. So it has this suction sails in the forward, which can be kept on one ship, or it can be containerized. In fact, a fleet of 10 ships can have 2 of these, which can be exchanged between ships which are in good wind conditions. So every project, every design that you can see now has something in it, which is sometimes it's a wish, sometimes it is a real attempt to make it green. And naval projects also, we see, again, there is an interest, but it cannot be changed drastically. But we feel incorporation of batteries for silent operation is probably a definite thing, and autonomous for sure. Because the first one, we had done a study, the anti-submarine case. We have, let's say, 1,000-ton displacement vessel, which can be easily replaced by probably 150-ton or less vessel if you remove human from it. Because the 70% of that ship is being designed for the people who are going there. The NBCD, the nuclear biological warfare system, the HVAC system, the entire system. So you remove human from a warship, which is good for people and good for the end user. You can probably have 10 of these ships built for similar cost, with meeting the same requirement or much better requirement, because the ship can only be at one location at one time, whereas 10 ships can be at 10 different locations. So these things are happening. Now about the potential in India, we have seen this huge market that is there, 50,000 ships to be replaced. And today, or if you really look at orders that happened this year, 75% of new building orders are in China. 75%, it's a massive percentage. And if we really look at the geopolitical scenario, there are many owners who really don't want to go to China. And in fact, some of the orders that we are getting in India are direct resultant of that kind of thought process. And with the kind of developments, you need countries who have enough manpower, who have resources, who have land, who have vision. And if you really combine all these things, we are at the right slot to get into this massive requirement of ships to be replaced. And last few months, we see a lot of focused attention from the government level, policy making level. Hopefully, we see that India will get into this real good opportunity of shipbuilding. We need a drastic change in our planning. We have still not understood the role that planning plays in the shipbuilding. Shipbuilding is definitely not a complicated, or it's not a rocket science. It's not something that requires too much theory, but it is something that requires the highest level of coordination. So many people have to work together to get a ship out in time. And so planning is very important. Skilling is really, really important. Today, it's almost impossible to get a 5-year experienced structural designer for a ship design company. And I'm sure each shipyard is facing this. And if you really look at, just to quantify it, 1 million GT of shipbuilding in a year requires about 15,000 trained people. And I have actually, in one of the slides, I've put how many million GTs have to be rebuilt. These are in thousands. So thousands of millions of GTs are to be replaced, and the amount of people required are enormous. And recently read about India having 65% of unemployment at high skill level. So you have an industry which can directly supply, and shipbuilding is a very special industry where every one employment in a shipyard creates at least 6 to 7 employments outside. So 1,000 people in a shipyard is actually creating at least 7,000 jobs outside. So we have an industry which is a perfect solution to the key problems that India has. And yeah, only thing we all have to come. And actually, I put this today morning, he spoke about scientific social responsibility. So this is something that my boss always talk about, individual social responsibility. So we see that the country is spending a lot of money on a lot of people. Each one of you is actually a beneficiary of that. And at the end of your course, when you move out, and if you're deciding to go out of the country, that is completely lost. The effort that the country has put on you is completely lost. And unless each one of us decide to put our effort here, stay back and do something, this will not really happen. The opportunity is there, opportunity will go. Somebody else will take it, or something will happen. But we will never be beneficiary of this. You will go out, or we will go out. Our next generation will also have to go out, because we are never creating an opportunity, or we are never creating a solution to the problem. So that's what I actually wanted to talk about as the summary, that this individual social responsibility is very important. We have to understand we are in a point of time where we are in a country which has massive potential recognized by us and the people outside. So make use of it, put your effort into it, and we have such a wonderful future ahead. Thank you, and I'm ready for any questions that you may have.
Yeah, Khatraj, yeah, thanks for the nice presentation, which is more practically oriented.
Yes.
And what you've been mentioning is that use of low carbon fuels like methanol and things like that. It is actually not going to do the benefit as expected. And as you said, these type of fuels can emit gases, may not be carbon dioxide much, or it can emit gases which are more dangerous.
Yes.
One thing. Second thing is the storage space requirement and weight increase of the design of the ship, which is actually not going to help much over the period. So any data, actual value of the data, when you compare a particular ship, you said 30,000 ton bulk, deadweight bulk carrier. If you consider these two fuels, is there any data on the cost and emissions and all that, which become more convincing for the people who make the decisions on, changing the fuel or going for the new generation vessel design and all that?
Yes, of course. Thank you, sir, for the question. The data are limited because the ships which have really moved to that and started using whatever is the green is still minimum. Second thing is the way the emission is being seen by the IMO. That's what we call the tank to wake, which will change to well to wake. That is, what is real emission that is happening when a fuel starts from the well to reach being used in the ship. That is not the present look. Right now is in the ship's tank, once the fuel is in the tank, once it is being used. And the moment you change the perspective to the next bag, many of these fuels become a big problem because already you emit a lot when you generate the fuel. Now, when it comes to cost, the cost of the ship, as I said, it typically increases from 25 to 30% if you put the fuel. So capex has already gone up. When it comes to OPEX, the money that you have to spend to buy the fuel, presently all are more, and of course it is available. And green fuel is, you're not even getting it. Then how do you really do? Very few companies right now. I understand, say Meta want to do whatever their transportation in green fuel. They have an agreement on either using green fuel or some green trading. So it's like you shift your problem to a second person's problem. That is, I feel the green trading mostly is like that. I have money, so I'll buy carbon from you, but somebody else will emit for that. And so right now, if you look at any of these larger vessels, a direct comparison of emission that is saved, unless it theoretically is there, you can always say 80% emission reduction if you use fully green fuel, but there is no continued operated data that you see the data that I don't think that is existing right now. There are key projects that are worked on very small scale, short distance. That's all. And theoretical.
The thing is it as the status based on the development status of now, as you said, availability and things, but does it have in the future if the things would develop further?
Yes, of course. In fact, all the projections are very clear. We will reach net zero by 2050. Somehow we will reach. So, and that I'm sure the industry will be pushed to that. So the designs will have capability to do that, provided the fuel is available. So I think all these technologies are now there. You can actually buy an engine which can burn methanol. Ammonia will be, hopefully by 1 or 2 years, there will be engine that can directly burn. I'm talking about two-stroke engines. It will all be there. So technology will be there, but how the industry will be there, I cannot. It's just we are going to see it. The biggest concern, as I said, is whether shipping is going to get the green fuel where there are many buyers in front of you in the queue. This is how we see it. Probably Mr. Sampath, so he can give you a much better view from the Class and K perspective on this one.
But what you have mentioned that is we are contributing less than 3% only to the emission side. And other people are, culprits, and even the policy decisions of COP24 and all that, the decisions what they made.
Yes.
And what the Trump, he said is a hoax.
Yeah, exactly.
So that's
if you read the annual reports by, say, IRENA, that International Renewable Energy Corporation, we'll see how each industry is functioning, and you will be amazed why shipping is being pushed like this. I always feel like that when I read that. Why shipping? Because it is an easy target, sitting duck, slow moving, big. So you target it.
I'd just like to add on to what was discussed. I think IMO has identified about 128 fuel pathways, depending on the type of fuel, the processing systems, refining types, and what electricity you use, and so on. But in addition, as he said correctly, the well to wake has got has a 5 different parts. One is the extraction part or a manufacturing part. Then you have the transportation part, then the shipping part. So now each one part has to be certified for whether they are green or not green. So in future, I think the IMO is yet to decide on the certification part. We have already decided on the certification part for the ship, but for the manufacturing, the transportation is yet to certify. That certification scheme is yet to be decided. And so you will have a fuel delivery note, probably instead of a bunker delivery note in future, which specifies the carbon factor. So ammonia may not be actually having 0, but maybe having a 0.1, 0.15. Again, it will vary from port to port. Even the same fuel in the same port may have 2 different carbon factors because the manufacturings are different. So we are going to have this system at least interim until we get to zero emission by 2050. But whether we reach there or not is again a question, because you have to ramp up your capabilities of production of the green fuels.
And this green fuel production, that's again, since we are on the topic, so wind is considered as one of the largest green fuel that will ramp up by 2030. And I have read that just to reach that target of wind production, the copper mining has to increase by 11 times. Now, mining is one of the most polluting industry that is existing. So we are actually talking about, it's a very strange picture. How do you make windmills right now? In fact, we are working on one of the designs where for this offshore windmill, where the windmill blade diameter, the whole diameter is 250 meters. So 125 meter blade with the nacelle, the hub, it weighs about 950 tons. And this is almost fully copper. There are no that much copper in the world right now to make all those windmills that we are planning to produce. So the poor Africans will get all those mining emission because they will sell, because it's finally you earn money in that process. So there are some apps you can download which shows the electricity production in the world or energy consumption in the world. You will see Europe is perfect green. The US is green in many areas. We are a brown. We are thermal. We are a dark brown country. But then what is happening? Many of the other people are working for these green countries for their green energy. So it's a very skewed picture that it's like a person with nice friend and all stabs behind.
Also at present, IMO is only considering the direct emissions.
Yes.
Than the direct causes of the emissions. That means the electricity that you're using or the manufacturing that is being done, it doesn't cause the indirect part, as he said correctly, is not being considered. For example, if you use biofuel, what is the wastage of the land that's being used? How much deforestation is taking place for that?
And how much food people lose?
Yes. So
like
those
people are
indirect causes is not being
people
considered.
are ready to pay for biofuel. You get nice usable cooking oil and convert it into biofuel by just making it dirty. So somebody is losing their food in that process. We are not really bothered about that process because somebody is ready to pay more for biofuel to burn in biofuel plants or whichever use. And another thing is the carbon capture. Actually, Shivaprasad sir had asked a question about the carbon capture thing. You burn, say, 1,000 tons of LNG. You create 2,000 tons of carbon, which is to be cooled and stored one way. So you need double the storage. So 1,000 cubic meter of LNG you need close to 2,000 cubic meter of carbon storage. And finally, you have to store it somewhere. Or you make it calcium carbonate and dump it in the sea or something. It is like you take it from somewhere, you spend more energy to make it a more complex thing. And somebody in Norway think that is a possibility, and then the entire industry is being driven. Whereas countries like us, who have to develop, we have to develop. We are at a, we have to develop to take our GDP forward. We have to do a lot of things, and our hands and legs are tied in this whole process. Unless we can emit, we cannot really move. And one good thing I noticed is actually day before yesterday, there was in the paper that if India has to reach the targets that we have to reach, 40% of women working women population have to come to actual producing work. And I saw University Coco Championship by Cochin Department of Ship Technology women team. So that's amazing because we never had people enough to make a women team when we were studying. So women getting into industry, I think will help the industry a bit in moving forward. But this, yes. But any questions from the students? Thought this is the future. Yeah.
Hello, sir.
Yes.
Sir, I'm a law student, so this is a little a question. So I heard a government pleader who was previously a maritime lawyer talk about a case, a 2010 case where a ship was stranded in the Lakshadweep area and it hit a coral reef. The ship was carrying cement, so the court ordered the ship to be not touched since the Wildlife Protection Act protects the coral reefs. So I was thinking about, and recently the judgment came and the ship can't be touched again. And the company is not allowed to retrieve the ship in any way because the coral reefs replenished around the ship. So I was asking, are there any design solutions that can overcome these legal barriers? And this case lasted for around 14 years. So I think, I believe that there is there's a big quantum of work behind building a ship and transporting. There is a lot of money involved. So are
Design solutions to avoid. If I understand, you're asking whether we can avoid, could we have avoided the collision? Is that the question? Or legal? Of course, that is you should answer that. You are the expert in legal thing. I think that should have been solved the next day, if it is my opinion. Yeah. Yeah. Yes. Yes, ma'am. I understand the question, but I mean, it's of course the legal process should have been fast so that it could have come out, or probably there should have been some means of pulling the vessel out, taking all the photographs, and then leave the vessel for its work. Uh, yeah, I cannot. Of course, maybe normally in these kind of collisions, probably you first try to remove all the fuel that can probably come out of it. So in design, we have this stability. I mean, I've heard. So what we try to do is the regulatory framework for a design has tried to make it as stable as possible and try to keep this pollutant like the fuel, which is one of the major thing. You cannot really keep it in the double bottom, of course, in the adjacent to the shell, you can keep certain amount of fuel, but there are certain probability calculation that you do. You say that even if there is a collision, it should not pollute. So like that, already regulations have come from 2004 onwards. If you see, earlier we could have kept fuel with shell, sharing with the shell. Right now you cannot. Certain amount of fuel can keep small quantities. So I think from the design and shipbuilding perspective, the International Maritime Organization and the marine pollution, there is a section in that for attending the marine pollution. They have already taken a lot of action on this. But I think the specific problem that you have raised is something the legal system has to find a solution of moving. I think this is what I can think of. Thank you. Yes, sir. Yeah, yes. Thank you.
Yeah, thanks, Hari. You left us with more questions than answers, I guess. So essentially 4 questions. Why? You've said IMO and the government regulations are pushing us through this. But why us? Why the shipbuilding industry is a question that we need to think about deeply. How we have covered a few, I mean, not a few, I think went through a whole lot of things, how we are as designers, shipbuilders, what we can do and how we can go forward. And there are a lot of areas where we can, I think, do much more. Again, then the question of who's bearing the cost. You and me have to pay for this. So that is another question that we all have to ponder, whether what is, are we in a vicious cycle? What is, that's, there are no immediate answers, but yeah. And then finally, what is the fuel of the future? It's a big question. I mean, as ship designers, you have raised that question. Shipbuilders, we know that we are doing something, but we don't know whether that's going to be the solution for the future. So these are, I think, interesting questions that, I mean, this thing you have raised very aptly, and I think all of us is to ponder as professionals. Thank you so much for a very enlightening presentation.
Now, I invite session chair to give a token of appreciation to Mr. Hariraj P. I invite Dr. D.D. Ebenezer, Adjunct Faculty, Department of Ship Technology, and retired scientist and chairman NP Oil, to give a token of appreciation to session chair, Commodore Rajiv Sridharan, CIO, GISC. A heartfelt thank you to all speakers and session chair for sharing their knowledge and expertise. It's the end of our first session. Now, let's have a delightful lunch arranged on the first floor, and please be back at 2:15 p.m. for the next session. Thank you all.